Okay, so I'm going to carry on from Lars, but move from brain imaging parameters to the psychosocial and lifestyle factors that we measure within the cohort. One of my research interests can essentially be summarised with the question of what lifestyle factors might predict successful cognitive ageing, what factors might protect the ageing brain. Just a couple of years ago, Herzog published a review article summarising the literature on various lifestyle factors which have been suggested or reported as cognitive enhancers, as they called them. So any lifestyle factors that had been shown to predict better cognitive ability or less decline over time in older people. In the summary, they suggested there was currently evidence to support the benefit of intellectual type activities and physical activities, exercise. The reason I'm interested in lifestyle factors, and other people are as well, is because lifestyle psychosocial factors are to some extent potentially modifiable. They can therefore be some sort of intervention suggested by them. They don't have to be necessarily complex or difficult for people to do, so the literature on physical activity and exercise has shown that even light to moderate physical activity such as walking can be beneficial. Because of that, the suggestion is that these things could be accessible. They don't have to be for certain sections of society. They're open to people from all socio-demographic backgrounds. Currently, though, because we're interested in the ageing brain, a key focus is on intellectual type activities, and everyone will have heard the adage, use it or lose it, and it is used a lot in the literature to try and explain why intellectual activities might relate to how well someone does in terms of their cognitive abilities over time. However, activity participation, be that intellectual, social or physical, in adulthood is itself an outcome. It's a behaviour that has been predicted by factors from earlier in the lifespan, and it's something that we'll come back to in a little while in the talk, and it's what Ian mentioned, the idea of reverse causation. And it's not just something that's of niche statistical interest that a factor from earlier might attenuate the associations. It's actually very important, because if people are interested in creating interventions or developing things to help older people maintain their abilities with age, if those interventions are based on spurious results, then they're never going to work. So what have we done to date in the LBC sample that is the focus of today's this morning's symposium? Well, in Psych and Aging just now, our first paper on activity in the LBC 1936 is available. And what we see there is that childhood cognitive ability, assessed at age 11, is a predictor of the kinds of activities that people will do at age 70. So over a 60-year span, childhood ability is a predictor of the activities. So those who do better at age 11 are more likely to participate in more socio-intellectual type activities at the age of 70. Because of that association, when you put childhood ability and adult social class into the regression models, the associations between activity and cognition at age 70 are then completely attenuated. So at a baseline level, these activities explain anything from 3 to 6% in cognition at age 70. But add in age 11 IQ, social class, and those attenuations are completely attenuated. So a lot of the results that are reported in the literature that aren't able to control for those things are explaining about 3 to 5 to 10% sometimes, but aren't able to sort of account for the fact that a lot of that association is due to the fact that these activities are themselves outcomes of earlier cognitive ability. However, in the LBC, we did find small independent effects remained for physical activity. They were much lower at about 1%, but they held at about 1%, even controlling for prior ability and social class. So those who were more physically active generally had better cognitive function and faster processing speed. So the LBC 1936 sample you've already heard about. So just to focus you in, we're talking about the folks tested at age 70, 1,091 tested at age 70, and I'm now going to be talking about the repeat cognitive testing at age 73, where we had 866 returning for a second session of cognitive assessments. So what we're going to be looking at is, we've already published on activity and cognition at age 70. We're now going to be looking at the cognitive change from 70 to 73, a short time span, but what we're interested in is cognitive ageing. The cognitive measures have been pretty well described so far. The names are here for completeness, but just to focus you in, we'll be looking at factors for general cognitive ability, processing speed, and memory, three major domains of cognitive function. Activity participation was measured in the sample by self-report. 15 common activities were assessed at age 70, so all the activity assessments are taken at age 70. So 15 activities, anything ranging from visiting the library, going to pubs and social clubs, participation in social groups. How often did the participants do these? And they rated them on a very simple scale from every day or about every day to less than once a year or never. And we're talking here just about the first, the principal unrotated component, first principal unrotated component, which explained about 20% of the variance in those items. And just as a reminder, age 11 IQ is related to people's activity. So people who did better at age 11 are more likely to do more of these socio-intellectual type activities. These are the models that we're going to work through. I'll do the first one in a stepwise procedure, and then the rest all follow from that. So what we have is activity, this socio-intellectual factor, age 70, is our principal predictor. So the partial eta squares that you're going to see are just for that factor. The other things in the model, I'm not going to show you the detail of that. So age 70 activity is the main predictor, and our outcomes are the cognitive domains at age 73. Model 1 controls purely for age and days at time of testing and sex. So in the first model, activity age 70 is accounting for about 5% of the variance in general cognitive ability. What we're interested in, though, is what effect remains after controlling for childhood ability and controlling for the same test completed 3 years previously. So in the intermediate model, we put in social class and age 11 IQ, and you'll see that the 5% variance accounted for is completely attenuated. Activity no longer accounts for any of the variance in general cognitive ability. And just to finish it off, it won't make any difference, the final model, adding in age 70 general ability, again, activities having no effect on that small time cognitive change. So to illustrate the reverse causation that Ian mentioned earlier on, what we're interested in are factors that are related to cognitive ability and cognitive change in old age. And in this talk, I'm interested in activity participation. What we know, though, is that prior cognitive ability is one of the key predictors of how well you're going to do later on. What we also know is that prior cognitive ability predicts a lot of lifestyle factors, behaviours, choices that people make. And in some cases, that either partly or wholly attenuates the cross-sectional associations that exist in the literature. Ideally, what we want to find are things that remain associated with cognition in old age once we've accounted for this early thing. But we have to account for this early thing, because if we don't, as I say, interventions designed around these sorts of associations would fail to have a robust effect. So just to complete the table, because obviously general cognition is only one of the domains that we're interested in. So we have processing speed and memory, exactly the same models as before. The baseline associations, again, activity at 70 is explaining about 4 to 5% of the variance in either processing speed or memory. Adding in age 11 IQ and social class attenuates the associations, and then the final model adding in the age 70 version of these cognitive domains, in one case attenuates it slightly more. But you see that an independent effect remains in this model for processing speed. What that final significant partial eta squared is saying is that accounting for how smart these folks were at age 11 and accounting for how smart they were at age 70, there's a small independent effect of activity at age 70 on how well they do 3 years later. A small effect, but remains significant after controlling for 2 previous versions of these cognitive measures. As I mentioned, we're also interested in physical activity. So physical activity, again, assessed by self-report, again, simple scale, running from the folks who were active only in connection with necessary household type chores, all the way up to keep fit and heavy exercise. It's a very nicely distributed variable, actually. And as you'd probably guess, most folks are in this sort of middle area, walking 1 to 2 times a week, or walking other outdoor activities a few times a week. So those are, most of our folks at age 70 were somewhere in the middle, with a few at the extreme ends. The interesting thing, and it came from the work that we did at age 70, first of all, is that age 11 IQ isn't associated in a simple correlational way as highly with physical activity as it is with those other types of activities. Exactly the same types of model again, and just to point out, we're talking about physical activity at age 70 is the main predictor in the model. Our 3 cognitive domains at age 73 are the main outcomes, and we're controlling for age 11 IQ and social class, and then the age 70 version of these cognitive domains. So you'll see that, first of all, in the first model, again, a much smaller amount of the variance is accounted for by physical activity, from about half to just over 1% of the variance. Again, controlling for age 11 IQ social class, there is attenuation of the associations, but it's a smaller degree of attenuation because there's less to attenuate. But again, we have a final association remaining. So the top line here, the summary being physical activity, those who are more physically active at age 70 are doing better at age 73, accounting for how well they were doing at 70 and at age 11. So as a summary of these recent findings, the associations between socio-intellectual activity and physical activity are confounded by prior mental ability. And when we're interested in cognitive ageing, it's an incredibly important thing to bear in mind, the reverse causation argument. So in terms of the socio-intellectual activity, the baseline correlations are about, the shared variance is about 4 to 5% are attenuated when controlling for age 11 ability. And for physical activity, it explains a lot less in the baseline models, but those are also attenuated. However, we are seeing some small independent effects remaining controlling for age 11 IQ. So we are seeing some small predictive effects of these lifestyle type factors and change over a short period. And you might say, well, 1% is not very much in terms of a percentage of the variance, but in terms of the most replicated genetic effect, for example, ApoE, in the LBC 1936 sample, ApoE, the epsilon-4 allele, accounts for no more than 1% of the variance in cognitive abilities in this same sample. So the lifestyle factors are accounting for about the same amount of the variance as one of the best replicated genetic markers. So what we have are suggestions that there might still be protective effects of some of these lifestyle activities over and above prior ability and ability some 3 years before. Obviously, we're only talking about 3-year follow-up at this point. Not a lot of change in cognitive function, not a lot of variance in the change in cognitive function. And Wendy will talk in a lot more detail about change over those 3-year periods. The cohort recruited at age 70 were obviously self-selected in terms of health, mobility, and their willingness to take part in a study such as this. But we are obviously following the cohort up again at 76 and hopefully beyond into the future. So we'll be able to look at longer-term cognitive changes, which is what we're probably all really interested in, the changes over 6 years, 8 years, 10 years. We're also interested not just in cognitive ability, but in other outcomes of interest. So although the associations are generally smaller with cognition and cognitive outcomes, there are generally higher associations with well-being and quality of life. And as Ian mentioned, other members in the team, that's their principal area of interest, how happy people are, how fulfilled people are. So although these activities often seem to have small effects in terms of cognitive outcomes, we are obviously following them up in terms of other outcomes of interest as well, including the prediction of terminal decline trajectories. So I'll just finish there by saying thanks to the rest of the team, including some of the folks named here who actually do the testing of the participants, and I'll take a question or two, I think. We've got time? Thank you very much.